Welcome to Study Loop.
This is chapter 21, problem number 38. We are asked to design a DC transmission line that can transmit power of 925 megawatts of electricity, 185 kilometers with only 2.5% loss, where we are to use an aluminum wire, and the potential is 660 kilovolts. Now, if you want our loss to be 2.5% of the initial power maximum, right? So power loss, as you know, is, I squared times R, the resistance, right? So we know that I times V equals power. So if I isolate I here, it's going to be P over the total power over the voltage that we have. So, and the loss that we have can be 2.5 divided by 100 of the initial power, right? It's 2.5% of the initial power. So this I squared times R, let's write it in terms of the total power. P squared over V squared then times R. This has to be equal to 2.5 over 100 total power, right? So in both sides, we have total power, so we can cancel them out. Then power divided by voltage squared times the resistance is going to be equal to 0.025, right? And also, we know that the resistance of a wire is proportional to its resistivity times the length of the wire divided by the cross-sectional area of the wire. So this is where our choice kicks in, right? Because what kind of the radius of wire or diameter of wire we want to use so that we can limit our losses to 2.5% of the initial power. So cross-sectional area is pi r squared if we have a wire, right? So the resistance is basically rho times L over pi r squared. Now we can plug this in the power loss equation. P over V squared times rho times L divided by pi r squared is going to be equal to 0.025. Now, what we want to know is obviously the radius of the wire because it's our own choice. So then if I isolate r squared out of this equation, I have total power times the resistivity times the length of the wire divided by 0.025 times V squared times pi, right? So if we take the square root of both sides, then this gives me the radius of the wire. Let me carry the same equation on to the next page. Then R, the radius of the wire, is going to be equal to square root of total power, the resistivity of the aluminum wire, the length of the wire, divided by 0.025 times V squared times pi. So before we plug in the values, as you know, what P is given to us, rho for aluminum is 2.65. You can look this up. It's on any introductory physics textbook. 2.65 times 10 to the power of negative 8 ohm meters. This is the resistivity of the aluminum wire. And V is given to us as 660 kilovolts. L is given to us as 185 kilometers, and we have the total power, 925 megawatts. However, I want to direct your attention to one thing. In order to complete the circuit, just one way of transmission line is not enough, and there has to be another way, right? Back to complete the circuit. So then actually, this L that we're talking about is twice the 185 kilometers. That's one thing that I wanted you to pay attention to. Otherwise, you're not going to get the correct answer. So when we're plugging it in for the radius, what we're going to do, power was 925 megawatts, right? So it's 10 to the power 6 watts times the resistivity 2.65 times 10 to the power negative 8 ohm meters times twice of 185 kilometers, which is 185 times 10 to the power 3 meters, divided by 0.025 times 660 kilovolts, but we're going to convert that to volts. Don't forget to square it, and then 3.14. So when you plug everything in, what you get for radius is 1.63 times 10 to the power negative 2 meters, which corresponds to 1.63 centimeters. So the radius of the wire at least should be 1.63 centimeters. This is the radius, right? If you want the diameter, you can multiply it by 2, obviously. But if the radius is smaller than this, 1.63 centimeters, let's see what happens. If that's the case, look at the resistance equation. Rho times L over cross-sectional area. So if your R radius is less than 1.63, then the denominator is decreasing. If you decrease the denominator, which means you're increasing the resistance. If you're increasing the resistance, then you're increasing the power loss, right? And you don't want that. So the radius of the wire that you want to use at least needs to be 1.63 or greater than that in order to have maximum loss of 2.5% of the initial power.